Right, for this question you've got three graphs that look like that, and then the question is, show that length OB is equal to length AB. So if you find where OB is here and AB is here. So what you need to do is show that these are the same length. So what we need to do is find the distance between the points. Now we know that this point is 0, 0. We can find this point here by simultaneous equations. We can find this point here by simultaneous equations. We can then find the distance of this line and the distance of this line, and if they are equal, then we've solved the question. So what we need to do now is find the coordinates of B. So B coordinates are the crossing point of these two equations. And the two equations that you need is 2x and 2y equals 11x minus 7. So we'll start here. So y equals 2x and 2y equals 11x minus 7. So we need to solve that to find the coordinates. So it already tells us that y equals 2x. So 2 times y is 2 times 2x. So you get 4x equals 11x minus 7. So if you put your 7 on that side and you put your 4 on the other side, 11x take away 4x is 7x, which means that x is 1. And if we substitute it back into the first equation, it also means that y is equal to 2. So our first coordinate point is 1, 2. So that's B. If you go back, what we need to do now is find the coordinates of A. Now A is the crossing point between this equation here and this equation here. So x plus 3y equals 0. So we'll start up here. X plus 3y equals 0. And the other equation was the one we previously used in the other part, which is 11x minus 7. Now, you can rearrange the top equation to read x equals minus 3y. So I'm just going to use that one. So if I substitute it into here, you get 2y equals 11 times minus 3y is minus 33y minus 7. If you put your minus 33y on the left hand side, you get 35y is equal to minus 7, which means y is minus a fifth. So if y is minus a fifth, you substitute it in to find what x is using this top equation here. It's minus 3 times y. So minus 3 times minus a fifth is 3/5. So we know that our coordinate is 3/5 and minus 1/5. Shouldn't be there. Now if you go back to the equation and then compare what we've got, our B coordinate was 1, 2, and our A coordinate was 3/5 minus 1/5. So 3/5 minus 1/5. So what we need to do now is find the distance between the 2 points. Now the distance formula is the square root of the difference between the x coordinates and the y coordinates. Added together and squared, just like Pythagoras. So if we have a look at the distance between the origin and B. So the origin and B is 1 minus 0 squared plus 2 minus 0 squared, which is the square root of 1 plus 2 squared is 4, which is the distance is the square root of 5. So we know that this distance is the square root of 5. So what we need to do is prove that this side is also the square root of 5. Now I'm running out of room, so I'm going to go to the other part. So it's 3/5 and minus a fifth. So it's the distance between these two coordinates here. So it's 1, 2 and 3/5 and minus a fifth. So we need the distance between these two coordinates here. So we'll do 3/5 minus 1 squared plus minus a fifth minus 2 squared. So the distance is, so 3/5 minus 1 full 1 is minus 2/5 squared. And minus 1/5 minus 2 full 1s. 2 full 1s is 10/5. Minus 1 minus 10/5 is minus 11/5 squared. And don't forget your square root, which is the square root of 4/25 plus 121/25, which is the square root of 125/25, which is the square root of 5. So OB was root 5, AB was root 5, so we also know that both of those are root 5, and therefore they are equal.